We have spoken of many burials and many fossils found, how they died, when they died, and even at what age they died. Have you ever wondered, though, how the age of the individuals that have passed were determined? Well, if you were curious about that, we have answers for you. The first feature that gives scientists a hint of the individual's age are the teeth. If fossil finds include teeth, then it makes the work of the scientist just a teeny bit easier because teeth can tell us how old individuals were when they died, especially if they died young. This is because teeth appear in a certain sequence and at particular ages. We know that our first deciduous milk teeth or baby teeth begin to appear at around 6 months of age. These gradually fall out during childhood about the age of 6 and are replaced by permanent or adult teeth. All our teeth appear in a certain sequence and each type of tooth appears at a particular age. For example, when we talk about baby teeth, lateral incisor appear at about 6 to 11 months of age, canine at about 16 to 20 months, and first molar about 10 to 16 months. And for our adult teeth, the ages at which they appear are central incisor at about 6 to 8 years, lateral incisor 7 to 9 years, canine 9 to 12 years, first premolar 10 to 12 years, and so on. So most of the information about an individual's age is gathered by looking at the types of teeth visible above the jaw surface or the gum line. That is the first step of examination. Additional information comes from examining the degree of root development deep within the jawbone. Ages are now also being confirmed by microscopic examination of tooth enamel. When tooth enamel grows, it produces tiny growth lines in the enamel. These lines can be counted to give the tooth's age. Sounds simple, right? But it is a whole lot of work done just to give us the correct numbers. So that's about how teeth can help scientists determine at what age an individual passed from the fossils recovered. Now we come to the bones. When it comes to determining age from bones, the first thing scientists look for is the growth plate. The growth plate is the area of tissue near the ends of long bones in children and teens that determines the future length and shape of the mature bone. Young individuals who are still growing have special growth plates in their bones, but by about 18 to 20 years of age or near the end of puberty, the growth plates disappear because the bones have stopped growing. Some bones begin to fuse together after the body stops growing. In humans, bones begin fusing from about the age of 17 to 25. As teeth don't all grow at the same time, bones also do not fuse all at the same time. Therefore, by studying the growth plates and the fused bones from the fossils, scientists yet again get few hints of the age at which the individual passed. Let me give you one example. Our skulls contain many bones that tightly join along lines called sutures. The sutures begin to fuse from about the age of 17, and some fuse more quickly than others. And in very old age, all the sutures are completely hidden by bone tissue. Up next is determining the age from the rates of development. To estimate an individual's age, it is important to know the rate at which their body develops or grows. Modern humans, for example, are slow to develop from a baby to an adult. We take twice as long to reach maturity as our closest living relatives, the chimpanzees. For example, human adolescence begins at about 12 years of age, but in chimps, it occurs at about 6.5 years of age. Diverging from the topic, let me tell you that we know we grow relatively slow. But what is not yet entirely clear is why we have the slow, steady development and live longer than species with smaller brains. One theory is that species with big brains are more intelligent and flexible in their behavior and therefore survive better for longer. Scientists suggest that a large and complex brain simply takes longer to grow and wire up, meaning that large-brained species mature later. Now back to the topic. Combining the evidence from teeth and bones with understanding about growth rates allows the ages of some of our early ancestors, particularly children, to be determined. Australopithecines developed quite quickly. Microscopic growth lines in their toothed enamel show that they developed at a rate similar to that of modern chimpanzees. For instance, the tongue child, a fossil belonging to the species Australopithecus africanus, was once believed to be about 6 years old when it died. This was based on the position of the child's first permanent molar tooth, which was just beginning to appear in the jaw. Comparisons with modern human children suggested an age of 6. But in the 1980s, a technique called computerized tomography confirmed that the teeth were developing quickly in a very ape-like manner. This showed that the rate of growth was similar to that of chimpanzees rather than modern humans. This new information estimated the tongue child's age as 3.5 years at the time of death. Animal growth lines counts confirmed this age. Early Homo species appeared to have developed at rates that were intermediate between those of modern apes and modern humans. A female panda species, Homo ergaster, discovered in Ethiopia and described in 2008, was shown to be wide enough to have birthed young that had brain as large as 320 cubic centimeters, about 30 to 50% the size of an adult Homo ergaster. This suggests that this species developed a large proportion of the brain before birth, like modern humans, and less of it during childhood, which is more ape-like. More studies were conducted and were found to support the notion that rates of development differ from species to species, which helped scientists determine not only the age of the individual but also the species. However, more detailed studies are in the pipeline. And with that, we have come to the end of the video. Thanks for watching and hope you liked it. Do drop in a comment telling us what you thought of the video and what content would you like to see next from us. For more related videos, check our channel out and do not forget to support us by liking our videos and subscribing to the channel. Till then, this is Halabella and see you soon in our next video.